afternoon.
Hi. Hi.
Thank you for being here.
Thank you for inviting me.
So you are the CEO of Sweden's SeaTwirl, a company that is developing a vertical axis turbine. So far, vertical axis turbines haven't managed to break through. What should be different about your technology?
You know, that's exactly the same question I asked when I was approached and obviously had to consider this potential role. I should maybe start by saying that I've spent my entire career working with floating offshore wind turbines. So I moved to Norway just about the time when Equinor, or back then Statoil Hydro, built Hywind. So I've worked with floating wind for about 15 years, and I kind of made up my mind in September last year at the conference in Aberdeen, because at that time I think it became clear that the industry is facing some significant challenges. And I really got the impression that we have come a very long way with offshore wind and with floating wind, but we see now that it becomes a bit binary. Either it has to be absolutely enormous, huge turbines, huge foundations, huge vessels, and the infrastructure investments that we have to take now is absolutely astonishing. So I thought that we probably need to challenge ourselves a bit and dare to think out of the box and dare to think unconventional thoughts. And when I looked into this technology, I asked myself, why would it work now when vertical axis turbine hasn't worked before? And the reason it didn't work before was, to a very large extent, that the overturning moment when the rotating, or the rotor is rotating like this, the forces at the bottom just becomes unmanageable. And for that reason, they just couldn't grow big. But SeaTwirl's whole idea is to let the rotor, the tower of the rotor, just extend down into the water and rotate along with the rotor. So this video should illustrate what it looks like. So, well, should I maybe press it over here? 1 second.
There we go.
So I think people know what the vertical axis wind turbine looked like, but the point here is mainly that you have removed the generator house from the top of the tower and put it at the bottom of the tower. And what happens then is that you significantly reduce the bending moments in the structure, and therefore you can also reduce the amount of steel in the structure significantly. So we think that we can have a lighter structure for that reason, that you don't have 49,000 square meters of swept area pushing at the top of the tower, but instead, not sure if we can start the video somewhere else, but therefore we think we can come down to about 200 tons of steel per installed megawatt. And I think it's a very important KPI for the industry, amount of steel per installed megawatt, or per megawatt hour for that matter.
There we go.
So now obviously we can see what it looks like. As you can see, the substructure is also rotating. It means that you have the shaft of the turbine just going straight through the generator house, and you have a ring of smaller generators around the shaft, making the components very light, and you don't need the big vessels to replace them. So the constraints around vessels, the big enormous lifting vessels with the cranes, that was a key reason why I thought we really need to think out of the box. Because there are so few of them, and they are booked up so far in advance that you almost need to have your own dedicated vessel for your project in order to be able to do heavy maintenance. We have learned, for instance, from Kincardine, that if you need to do heavy maintenance, you need to disconnect the turbine, take it back to shore, do heavy maintenance in the harbor, and then go back out again. But the whole point here is that no component, even with a 10 megawatt turbine or larger, should weigh more than 15 tons. So we have basically a design criteria for the generator house that the vessel infrastructure in the market can kind of decide how heavy the components will have to be. So that's the fundamental point here. Much smaller vessels, much more available vessels, and also less steel in the structure. And the whole point is that we have removed the generator from the top of the tower and put it on the surface. So the way forward is that SeaTwirl installed its first prototype back in 2015. It's been in the water since then. It's still there and working very well. It has validated the models. It has also proven to many of the parties who have been interested in this, they can come and visit it and actually see that it's there. We are now building the S2, which is going to be installed next summer. The blades are ready, the generators are ready, the struts are ready, but the tower and the spar is still to be built. But the plan is to have that one hopefully ready by next summer and installed in Norway. And then when we have taken the steps with the smaller turbines up to 1 megawatt scale, we think we can possibly take another step to 5 or 6 megawatts without introducing pitch system into the turbine. And then when that has been proven as well, we can hopefully take the step up to the utility scale as well. And if it's going to be a 12 or a 14 or a 16 megawatt turbine, we don't really know yet. But it's a major step to go to pitch, but that's clearly something we're aiming for. And as you all know, floating wind has this hockey stick curve when we approach 2030. So if it all goes according to plan, we will have a proven model by then. So when the Norwegian projects, the French projects, the ScotWind projects, and so on are really going to go to FID, we think and hope we can have a turbine available for the market.
And do you think that what's the place of such vertical axis turbines in the market? Are they just a nice add-on? Are they needed? Are they a gadget?
I think there is a big market for smaller turbines, and there is a big market for fewer turbines. There is a demand for electrification of oil and gas assets, for instance. You have hundreds and hundreds of fish farms that also need renewable energy to be powered. And then obviously you have the utility scale projects, the gigawatt scale project as well. So I think in the smaller markets, there isn't really anyone delivering small turbines, offshore floating wind turbines to that market. Either you will have to be 10 megawatt or more, or there isn't really any supplier of small turbines. So that is definitely a key market for us. But in the utility place, there is obviously the conventional turbine suppliers and the conventional technology, for sure. So we'll have to see if we can be competitive there, but clearly that is the ambition.
Do you think that you're going to be much cheaper than other turbines?
Well, certainly, if our hypothesis is right, that we can use significantly less steel, we can use significantly smaller vessels, available vessels, of course it's going to be cheaper then. So there is a way to go, and you have uncertainties and risks, like I mentioned, the pitch system. But just the fact that you can be able to use the monopile supply chain, that is the whole point there as well, that we shouldn't have to use these huge yards where you take almost a month to build a single foundation. We know it takes about 48 hours to build a monopile, and it's the monopile we're going to use for our foundation. So that's another aspect as well, just the speed of construction.
Okay, and what kind of markets are you looking at? What countries? Everywhere, or is there a special market you're looking at?
Now, I mean, for now, we obviously have some limited resources, incredibly busy with the opportunities that we have today. And we are focused on what I call the catalyst market, which is the offshore electrification of oil and gas. That is what's going to take us up to the bigger models. So for now, we are looking at the sort of small models, small turbines around 1 to 5 megawatts. And then in a couple of years, we'll go for the utility scale.
Okay, all right. And are you cooperating already with other companies that could provide all the future materials you need, the vessels?
Absolutely. On the whole supply chain and development side, we have a number of partnerships, and we are a Swedish company, so we also have really strong relationships with the sort of big Swedish industry players. And that's, I think, important. If you're going into the turbine space, you need to have the industry sort of backing you or behind you. But also on the customer side, we have signed an MOU recently with a Norwegian company called Contiki Winds, solely focusing on electrification of offshore assets like oil and gas and fish farms. So that's very exciting for us as well.
Okay, and you can see that Fanny has been listening across this innovation pitch, our wonderful graphic illustrator, talking about easy access, smaller vessels, lower costs. Does that sum it up, or is something
it
missing
really does.
there?
I think it was nice. It was nice. So I mean, like I said, I've spent 15 years working with the conventional turbines. It's already a huge industry, and I was triggered by this challenge that we're now facing, and just try to look at the horizon and try to live up to my own statement saying that we need to dare to think out of the box, and then that's why I took on this challenge.
Well, good luck. Thank you very much.
Thank you.
Thank you for listening.
Yeah.